You're about to listen to the Complete Developer Podcast, the podcast by coders and for coders about all aspects of life as a developer.
I'm Will, the curmudgeonly experienced developer.
And I'm Beej, the optimistic newbie developer. Welcome to another episode of Complete Developer Podcast. Before we get started, Will, what have you been fighting this week?
Well, I've been enjoying my first new week at the new old gig. It's I don't know, it's different because the contracting thing kind of puts a lot of stress sometimes, to make sure you got enough hours because, if you're a little bit under, that's money out of your pocket. And if you're a little bit over, that's, somebody wanting to know why money's coming out of their pocket. And it feels like a kind of a bridge to a bit more ownership of what I'm working on instead of me being, I don't know, it's like the difference between being the guy that's hired to build a shed and the guy that's building his own house or that's fixing up, a place that he's living, and that ownership factor is kind of something that you miss a lot as a contractor. So that's been kind of nice.
Perspective. Actually, my mom asked me the other day when I was telling her about, you going from contracting to being an employee there. She asked if this was your first full-time job. Because in her mind, you had been a contractor since we graduated college.
Wow. I mean, I've done it off and on.
That's what I explained to her.
Yeah. I mean, and I'm not completely cutting out all the contract work. But what I am doing is making it so that is not the bulk of my income. One thing is, I like the place I'm working and I like the people I'm working with. But the other thing is that I'm kind of looking at the economic situation and I feel like the local development market is overheated, and at some point that's going to go sideways. And I'm thinking that it would be a whole lot better to be somewhere and be stable and be valued member of the team whenever that hits, as opposed to being the new guy that has to come in and hit the ground running, or there's 10 other starving developers out there So that's kind of a better setup. And the other thing too is, I discovered that initially with the contracting stuff, the plan was to do that and then transition into full-time, self-employment. And what I discovered with the consulting role is that what ends up happening is you're consulting and during the downtime, you don't work on your own stuff because you're having to try to find more work, or you're having to try to train up, or you're burnt from, some of the stuff, because people throw contractors into it's sort of like conscripts in an army, in a medieval army. If you remember Braveheart, the Irish guys that ran to the front and got, like that's who you are most of the time when you're doing consulting. And so you end up coming home and there's a lot of days you're just beat. It's very difficult to get anything going. I still have my side project. We're still working on it. And now I'm hoping that will kind of ease up some of the psychological pressure on me.
Cool.
Yeah. So what's going on with you?
Well, I have actually been working on something for you. You kind of got me into Hexo, and I spent the last week working on actually 2 themes for Hexo. Working on the one for your company website, and then I'm also working on one for my own website because I'm going to switch over to Hexo as well. Honestly, the thing I really like about it, and we've been talking about moving the podcast site over as well. But what I like is
the podcast site's a little more complicated, though. Unfortunately,
yeah, it is.
but the thing is we don't need the dynamic code for a lot of the stuff that we're doing. It's just like I need to put text on the web, like I basically need front page without it being horrible and without it being front page. Like I want to edit text files and process them.
Well, I've been learning a lot of EJS. Started picking up some SAS because I found out about a really neat thing you can do with SAS.
What, like variables?
Well, variables, yes, but that isn't another nice thing. But what really, I guess, the straw that broke the camel's back of me learning SAS was I was looking through some of the other themes just to get ideas on how to do what I wanted to do. And a lot of them, their CSS is written in SAS, and they would have I guess it's like embedded classes. So like you could have ID top menu, and then underneath that, like inside of that, you could have UL, and inside of that, LI. Yeah. And so everything in top menu gets all of those, but, you know, UL only gets the stuff within UL, and LI only gets the stuff within LI. And it's made my life so much easier because I have written CSS that had like dot breakdown P dot breakdown H3 dot breakdown this dot breakdown that, like the same, and I could have put it all like that.
Yeah.
And it would have been so much simpler. And
and you can organize it. You can actually tell what you're looking at.
Yes.
I mean, CSS is sort of like assembler. It's optimized for what's reading it, not for the person writing it.
Yes.
And, you know, so it's almost a write once language. Mm-hmm. Because, well, I mean, like the website I'm working on right now, we've got a lot of CSS.
Yeah, I can understand
and
that.
We can't get rid of any of it because we have no audit trail to say, okay, this isn't used anymore without a tremendous amount of pain. So it's
that's rough.
Yeah, so it just rolls up like a snowball. And I think SAS is a necessary step towards getting that fixed because, you know, with the tools, the tool chain that SAS has, you could probably also build something to say, okay, is this actually getting used?
Do you know about style?
Style.
STYL.
Hadn't heard of that one.
It's CSS. It's like EJS for CSS. There's a lot of acronyms, but basically you can put JavaScript in the CSS.
So it renders the CSS dynamically.
Yes.
There's I've seen stuff that does that, I think in Ruby maybe. There was some gem that did that. I remember I'm sure there's some Ruby developer that'll go, "Oh, you did Ruby and you can remember that?" And I'm like, "Yeah, you know, I've done just about everything at some point." So that's But yeah, CSS really feels like it's sort of like some of the source control tools that we talk about. It's the worst tool for the job except for not having a tool.
Yeah. Yeah.
You know, it's sort of like a fire extinguisher / triage bandage. Oh. You know, like, okay, you're dead if you don't have it, but it's going to make a mess no matter what.
Also, I learned how to add some dynamic ability to Hexo pages.
Okay.
So, trying to get the CSS to work, I learned that the only way to do that with the theme is to put it in a source file. Like, under your theme, put it under source.
Okay.
Because otherwise, it doesn't generate.
Oh, yeah, so it runs all the templating EJS stuff.
Yes. Yeah. And so what I found was you can also put JavaScript in there.
Yep. It'll do wonders.
Yeah, it renders it as JavaScript on the page. And so I've been kind of playing around with that, basically trying to get things to where we can move this site over. But it's been a lot of fun. I've really enjoyed playing around with the Hexo. Done that, and so far as my .NET work, getting pretty close to finishing the project I'm doing for the podcast, which is taking our statistical data from the CDN and putting it up on a mobile-friendly site.
So I guess with that, it's about time to get into the episode. Roll the music.
Let's roll that music. This week for IoTs, we're going to continue our March is for Makers. Hey, have you ever wanted one of those home monitoring systems like Nest or Hive, but just don't trust them and think you could do a better job? Well, now you can build your own.
Really?
You like my advertising there? Yeah, it's...
And the affiliate link will be in the show notes, folks. Thank you. Not really.
Honestly, though, it's from the same blog as last week on hardware hacks with JavaScript, and it's build a simple home monitoring system, basically with an Arduino and Node.js server using WebSockets. The hardware that you need for it is an Arduino Uno, a solderless breadboard, one TMP36 temperature sensor, and 3 jumper cables. The software, just like in the other one, uses the Johnny 5 library. It also uses the Express library and the socket.io.
Okay, so what can you do with it?
Basically, you can create WebSockets so that it will check the temperature and send you updates on the temperature of your house. It's basically a monitoring system. This particular setup doesn't control the thermostat or anything like that.
Right, but it can report back.
Yeah. And
interesting. I wonder how well you could do that with like a moisture sensor.
I would think it'd be pretty easy to set that up too.
Because where I grew up, they have a lot of nurseries.
Oh, that's a good point.
And you have some people that have hundreds of greenhouses. Granted, now getting network connectivity may be interesting because it's a moist, hot outdoor to indoor environment. You're connecting in. There's going to be water spraying all the time.
Yeah.
But if you can get that into a setup that can both sense the moisture and not be in the moisture, there's people that would probably be very interested in having something like that because, when the water cuts off, it can cut off, for a day and they lose everything in that house.
I can see that.
It doesn't take very long at all.
Yeah, if you think about the IoTs from last week, we talked about a moisture sensor for the talking plant, and this is basically just home monitoring and not plant monitoring. So you could have a moisture sensor there that...
Yeah, because it wouldn't really be that... I don't know that it would be that terribly difficult so long as you could find something that you could... Well, I'm sure you could alter the code. After all, it's JavaScript, and it's all open source if you believe enough.
Exactly. So what are we talking about this week?
Well, this week we're going to talk about refactoring.
Refactoring. Fun!
Yeah, well, and you and I discussed this for a while. We discussed technical debt, refactoring code, and you're like, do you think we can get an episode out of it? And I'm like, I don't know that we can just get one. Because that's been about 75% of my career. Like I've made my living probably since, the second job out of college, second or third one, cleaning up bad code, or old code or code that no longer fits what people are trying to do. So, to start off, let's talk about what refactoring actually is.
Okay, because as I understand it, a lot of junior developers, when they first start out, do some refactoring.
Yeah, they do.
In part to kind of learn the system, and in part because the more senior developers don't want to do it.
Yes, it can be a good thing to throw off on a junior dev, although you've got to be a little bit careful because it's depending on what the system is.
Yeah, well, that makes sense.
What part of it. But the Wikipedia definition is code refactoring is the process of restructuring existing computer code, changing the factoring, without changing its external behavior. Refactoring improves non-functional attributes of the software. That's what Wikipedia says.
What do you say?
Basically what it means is making the internals of the app less painful. So anything that you're working with inside the application that is a pain point, it's ways of getting rid of that or making the app where it's more extensible. We'll get into some of the reasons for it, but basically when you hear a developer say that, they're not using the Wikipedia definition because that definition really doesn't say a whole lot.
No, it doesn't.
It's just like, oh, hey, I'm moving some pieces around and it's inconsequential is effectively what that definition says. And that's not really on point. Because the idea is, hey, I'm organizing things.
Question is it on fleek?
Is it what?
On fleek. On
fleek. I've never heard this term before.
I don't know. It's like a new millennial term.
This would be why. I'm thankfully quite sheltered from some of that by the gray hair in my beard. And so, yeah.
By the gray hair of my beard.
Let me tell you about the Great War, sonny.
So now that we know what refactoring is, why would you need to refactor code if you did a good job of coding in the first place?
Well, the first thing is there's a bit of an assumption in your statement. Nobody does a good job coding in the first place. Whatever code you're developing, it's a fountain, not a statue. You don't typically build things unless you're doing like embedded programming or something. You don't build things that the world doesn't change around, right? Your code is going to be under different constraints. The business that it's running under or the governmental entity or whatever is going to have different requirements, from regulatory requirements to security threats to scaling needs, all that kind of stuff. So whatever code you wrote initially, even if it's the best code in the world, given enough time, it will become garbage. Pretty much. I mean, as far as like actually meeting what the environment is.
It's like you either die a hero or you live long enough to become a villain.
Well, it's physics. It's entropy.
Isn't that the same thing as what I said?
Yeah, but you had a little bit more flair. You only want like 57 pieces of flair. You went to 58, bro.
Oh.
Yeah, you're fired from tchotchkes. Anyway, so some of the reasons you would actually refactor code. The first is improving the ability of developers to troubleshoot problems. This is usually the leading edge of the refactoring work that I have to do, is when developers can't actually troubleshoot. They can't figure out what's going on. So.
I know I've heard about you going out after 2 or 3 other programmers had been sent out to work on a particular problem because they went out and couldn't troubleshoot the problem. And your expertise is kind of in refactoring and troubleshooting those kind of problems.
That's a nice way to put it. Another way to put it is referring to me as a poo shoveler.
I'm trying to build you up here.
Clean up the mess.
I'm trying to shuffle some of my flair onto you.
Oh, that sounds like a euphemism. Anyway, so the basic idea is make it where developers can actually tell what's going on when something's going wrong. That I find that tends to be the first thing that starts this whole cascade. The next thing is to increase the speed at which developers can surface new functionality. And this is something I ran into at work the past couple of weeks. We have an app that we're working on, and there's some older code in there. Because of the way it was structured, if you want to add a new web page, it's not as straightforward as add a web page. Because there's the whole, there's the site skeleton, there's a bunch of stuff tied into session, there's a bunch of stuff tied into the security model. There's a base page, couple master pages interacting, there's scripts interacting with that. There's
a lot going on.
Yeah, chaos, panic, disorder, dogs and cats living together, all that.
Spaghetti code.
Yeah, well, it's not spaghetti code because spaghetti has coherent pieces. But it's code that's had a lot of hands, and the requirements have changed, and the approach of the coders has changed. There's been different coders.
Let me just ask: how long has that code been around?
It's been around for 2.5, 3 years, something like that, and it's had probably 4 or 5 hands in it.
I would think that it's one of those things. The longer it's been around, the more things have changed since it was originally written. The more people who have come in and made alterations to meet those changes. Yeah,
it's like an old house. If you've ever, and this is something that's not as common in America as it is in, say, Europe, but if you go into like a 120-year-old house, the corners of the room aren't square. It doesn't, like you put a carpenter's square there and there's, it's quite a few degrees out of angle a lot of times, and the studs are not where you expect them to be in the wall. There's weird electrical wiring stuff going on.
Especially in houses that were built before
building codes.
Before building codes, but before electrical wiring was commonplace.
Or air conditioning.
Oh, yeah, I've seen that.
Or, another thing, like you'll see, even around here in the older houses, they have higher ceilings because in the South it got hot in the summer and you didn't have air conditioning. That helped. They had breezeways through. Well, now you want to keep the temperature climate controlled and not waste energy. Like you have a completely different set of constraints. So it is kind of like working with an old house.
Yeah, it makes
It's just that sense. It ages a lot faster. Basically what happened is that every time that we had to add a page, there was all this boilerplate and all this other stuff that we had to do that was not relevant to actually what we were trying to build.
When you say boilerplate, what do you mean by that? You said it a few times throughout.
Effectively, what it is you have common code or close to common. It's a little different than copy and paste. Like it's copy, paste, and alter code.
Okay.
Because somebody didn't break it down enough and go, okay, here's the parts that change, just change those and make it available otherwise. And so what they did is they said, okay, I have this working on one page. Let me copy and paste it to the next page and just change the bits I need to change. And it's multiple hundreds of lines.
Oh, so that I'm connecting the pieces here. And from when you were talking about when to use templates.
Yeah.
And using them with boilerplate code, because when I looked up boilerplate code, I did not get that definition.
Yeah. Well,
I don't remember the exact definition I got because it was a while back, but it didn't make sense to me, and it was already after the fact, and I moved on. So that's why you bring it up again. I asked, and that clicks now. I understand what you were talking about in that episode because of your definition here.
Yeah. And so that was really slowing us down, right? It's like if we can improve this, we can react quicker to market changes. We can react quicker to customer input, errors, whatever else is going on versus, okay, well, I want to add a page. It's going to be a day of work to be at a point where I can actually add the piece I need to add.
That's ridiculous. A whole day to add one page.
Well, I mean, it's like 4 to 5 hours. Like it.
Oh, yeah, but I'm just saying, it's still...
Yeah, like you don't want to do that. You want to go, okay, I'm adding a page. Here's the bits that change. Leave me alone and let me code it.
I would say 4 to 5 hours that's half a work day.
Yeah, it took like 3 or 4 days to get this pulled out. So you think about like how long the time is before you get a payoff. Another reason you might refactor code is to actually improve testability. And a lot of this comes down to how things are wired together. If you can't separate things cleanly where you can actually tell where something is going wrong, you can't test, or you can't insert a piece in there that gives it a certain input so that you can test an input versus an output and make sure that a component is right. Like it's like it goes into a black box.
So I have a question for you. Do you remember the blogging engine I've been working on, following the tutorial? The trouble I've had with unit testing there. I wrote the engine a certain way and then had to go back and rewrite parts to do the unit testing. Would that be refactoring?
Yes. So it's something, basically the idea is you're making code changes that are not intended to be surfaced to an external party.
Okay.
It's code changes for organizational structure or for management structure or testability or things like that are internal to your organization, not to the surrounding parties, unless they're API integrations, in which case that whole thing falls down again because you would refactor to allow that. It's one of those fuzzy definitions, and honestly, you're not going to refactor without changing external functionality because that's not a thing. Like you alter something, you altered it. At the very least, you're going to have to change testing. Another thing that might drive you to refactor is trying to decouple internal components. So you have different pieces of the app that are talking to each other. When part A is dependent on part B and part B is dependent on part C, which is dependent back on A, and that's dependent on D, which is dependent back on B, that gets to be a real problem when you want to upgrade. I don't know, let's say you want to upgrade A. And if you have a massive dependency chain like that, it can be really, really painful because you upgrade A and then B gets busted. So you got to fix B. Oh, now C's busted. And you tweak it. Now A's busted again. So you may actually want to refactor just to get to the point where...
It's almost a recursive dependency chain because if A is dependent on C, B is dependent on A, and C is dependent on B...
You'd be shocked how easy that is to get happening, though. It's one thing when you do it inside of, like you have libraries and DLLs that are dependent on each other. Your compilers and the other tools can catch a lot of that. Where it gets weird is when you have something that's, okay, there's a process over here and a process over here, and they're passing messages across a bus. And there's no code dependency, but there's operational dependency.
Yeah.
And when you break, and so you would want to refactor just to get that removed. Well, you're adding functionality to the system at that point. So the definition breaks down a little bit, but it's still the same kind of thing. And again, I don't necessarily 100% agree with the Wikipedia definition because I don't think it really says anything. So another reason would be to reorganize code in preparation for future operations. This is hitting a lot of people right now with the mobile space. They have, old big websites that were, designed to run on a computer screen, basically. Mm-hmm. And now suddenly they have to support tablets. They have to support iPhones. They have to support potentially the Apple Watch. They don't even know if they're going to have to do that, if that's going to flop or not. And so a lot of them, it's already hit. And, their markets are at that point. Most other markets are asking, though, going, hey, I want this on a tablet. And so they're having to make code changes in preparation for that. They don't want to break their external functionality, but they have to start teasing things apart so that it's easy to change pieces out.
When I talked to you about writing the mobile app for looking at our podcast statistics, you were very highly encouraging of that because it would give me experience and skill in that area.
Yeah, but people have to pull stuff apart because there's more stuff coming in.
Mm-hmm.
Like things change, and being able to react to changes you see coming on the horizon. A lot of times there's a lot of lead up to that. Otherwise, you can't get there from here.
Well, it's just it makes sense because you come out with a brand new product like the Apple Watch, the other smartwatches. Apple's not the only one that has them now, but the smartwatches, if you don't put a lot of lead time there.
Yeah, there's no market for it because there's no ecosystem. It's like, oh, good, I got a new smartwatch, and the only application that runs on it is the time app. Yeah. That's mechanical.
Yeah, exactly.
Or digital, whatever. It's like you drop the ball. That's why they give all this big lead on this kind of stuff. Like, it's coming. The Oculus Rift is coming. You've known that for a couple of years at this point. Maybe a little too long in that one's case, but
there's other. Microsoft has gotten into it. Well, they're more augmented reality, but some other big names have gotten into the virtual reality world because of the hype behind the Oculus Rift.
Yeah, and everybody's having to play catch up on their apps at this point because, like, hey, that's great that it works on a screen, but everything's completely different if it's VR. It's like, okay, I may have the same data streams, maybe, and maybe they'll be shaped somewhat the same, but maybe they won't be, and I have to provision things where I can do that if this gets to be a thing. And so a lot of times refactoring will happen to prepare for this sort of stuff. And the last reason why you would refactor is actually breaking components apart so you can iterate on them separately. And you see this more in a lot of bigger systems because the company will build an app that handles all their stuff internally. And then as they start to scale up, like if they go to franchising model, all of a sudden it's like, well, there's the accounting app needs to be separated from the other thing and have a well-defined set of interfaces because now our development team gets too big to be able to function effectively. So we need to break that app up. So it's more of an organizational concern than it is a code concern.
Yeah, that makes. I can see there's reasons for combining things within the code and for separating them.
Yeah, it's basically the idea of I want to reconfigure my code to best survive the environment that it lives in. That's an evolutionary process.
See, now that sounds like a good definition of refactor.
Yeah, that's why I don't write for Wikipedia, because I write reasonably good definitions.
All right, so now we've talked about why you want to refactor your code. Let's kind of look at the opposite, and why would you not want to refactor code? Like, what would be involved that would cause you to not want to have to do this?
The biggest thing I've seen is organizational inertia. This code works. Why mess with it? Well, smoking 6 packs of cigarettes a day works until it doesn't, and then you die. And I don't want to put things in like just that blunt, dark term, but
yes, you do.
Yeah, okay, I really do. But a lot of companies, they'll do that. They'll ignore major underlying problems until it's too late to deal with them. And if you change it, then you've got to put development resources on it. You got to put testing resources on it. You've got to deploy. You've got all this junk you got to do. It gets costly, and plus there's other things that come into this. I mean, there'll be interpersonal disagreements about how to proceed. There's egos invested, right? Like the guy that wrote the system 20 years ago is sitting right across the desk from you, and you say, "Hey, this code sucks." That doesn't work.
Yeah, I would think this is one of those times where you kind of need to play some office politics.
Yeah, you kind of do, and part of it is just being a decent human being. I mean, that's what a lot of this stuff really is. It's realizing that the technical considerations are important, but that's not the considerations that the business and other stakeholders have. Because, like, for instance, if you want to refactor an application to make it where it can handle mobile, there's going to be certain things that are going to go away within the app. If you want to make it where it can scale better, some stuff goes away. And you may think, okay, well, like what? Well, let's say ASP.NET, for instance. Right. ViewState's a good one. Let's go with ViewState. ViewState is a set of form fields that get passed around so that you can keep state on the control, so you can pretend like the web is stateful when it's not. Yeah, it's a broken abstraction that they've moved away from. Well, what does view state enable? It makes it easier to program to a degree. If you're making simple forms and things like that, it's way easier than MVC. The problem is as soon as it stops being easier, it stops really, really quick.
It's a very abrupt cliff.
Yeah. The other thing it does is it's a big honking payload. So when you load up a website that's an ASP.NET web forms, and it's got that massive view state that's passed down to the client, that works great on a laptop. What does it do on your Apple Watch with limited bandwidth, limited battery? Okay, what happens to your screen layout? You're going to lose things by changing it where it can support this, but if you don't change to support it, you're going to lose the business. Because the world is changing, the business has to react, and it can't sitting atop old software. That said, you still have to deal with human personalities because people are not really good at forecasting change. They're good at reacting to it. Another thing that will keep you from refactoring code is volatility in your tool chain. This is something I've run into with a lot of JavaScript stuff. Like I was like, oh yeah, I'm going to do a bunch of stuff in Angular. Oh wait, they're ripping the guts out of it to make Angular 2. And I feel the same way about .NET right now. I'm looking at it going, okay, there's some things I want to build. And I was going to build them in the old version of ASP.NET, but now that they're changing so many things in the next version, including some things that I use, that volatility, the potential that, hey, this platform could completely change out from under me. And so not only am I losing, the code I've got, but I may be losing the ability to build the next thing because, if I move to this right now, they may break it 4 times before they get to a point where I can actually do anything with it. That will hold people back because, it's a risk.
It's like I was listening to another podcast. They were talking about why companies, are running older versions of .NET and, MVC or not MVC, but ASP.NET and things like that is because they work really hard on this app, and right before they roll it out, a new version comes out that has breaking changes. And they're like, all right, well...
Or they just don't trust it. Because, if it's a Microsoft product, you better wait till Service Pack 1. That's established in the industry. You don't jump to the new thing. Well, then what happens? Well, you've got a running app out there that's an old version. Well, now you've got to completely test. You've got to make sure every little corner of the thing works like it's supposed to. And so it's a cost. And so toolchain volatility will get in your way. And a lot of people, the mindset is just wait till it calms down, then make the move. Once the smoke clears and you know where you're going with it. And those people don't develop in Node, right? Because the smoke never clears in Node. That's one of the things that makes it awesome, but it's one of the things that also makes it painful. And a lot of environments or, a lot of platforms lose a lot of people when they make major breaking changes because of this, because they go, well, if I'm going to have to change it all anyway, I'll just go to something else. I'm wondering if Python is going to get burned by the same thing, after the changes for, going to 3.
Well, from what you've said before, a lot of Python programs are just refusing to.
Well, it's not necessarily so much refusing as they can't pay the bridge toll effectively because they got to go back and change a lot of stuff that may have been around for years and years and written by somebody that isn't there anymore.
What it makes me wonder is if something new comes out and nobody uses it, what happens in the next version? Does the next version go back to the way things used to be?
No.
Or do they try to make...
They try to make a bridge. Usually most successful platforms do that, but sometimes you can't because they're refactoring too. Another thing that gets in the way is the inability to comprehend the existing system. You'll see this with older systems, I guess is the best way to put it, or large governmental systems or, big internal corporate systems where the guts of the thing were written 15 years ago by that guy with the glorious, 1.5 long ZZ Top neck beard. And nice. That guy's retired or he's dead or he's the head of the department now and hasn't coded in 10 years.
A little side note, the longest beard ever on a living person was 17.5 feet long and is currently stored in the Smithsonian.
I take it not attached to the person. That's good to know.
Yes.
However, that's something that actually happens. Like if a system has been around long enough, you don't know what all is going on with it. This is, by the way, why we tell people to reboot their computer when there's a problem. There's enough moving parts in there. We have no idea what's wrong. A lot of times, like it's just chaos. It's like, okay, well, some guy at Microsoft, at some point, in 1992 at 2:00 in the morning on Christmas Eve, wrote this piece of code because there was a memory leak, because malloc wasn't working in this particular way. And this dude has moved on, like, he decided after that to quit programming and become a yoga instructor in
Bora Bora.
He just was done. And, well, what are you going to do? Well, the guy that institutional knowledge is gone.
Yeah.
And everybody that knew that institutional knowledge existed is gone. Mm-hmm. You're like third or fourth order ignorant by the time the problem rolls around to have to be fixed. And if the system has been sitting around long enough, you will have this kind of stuff happen. And it really doesn't even take all that long. I mean, you forget code you wrote a few weeks ago. If it's not particularly interesting or anything, if it isn't part of your growth curve, and there's a lot of resistance to change just because of that. I'll give you a good example. Back, I think this happened all the way up to at least Windows 2000 because I can remember doing this. The way that Windows get rendered, there's a message loop, and so you process. You go, hey, do I have any messages? Hey, do I have any messages? And you go, oh, I got one of these, and you have a switch statement. This is like way down in the guts. And you have different messages. So like you have WM paint, which is the paint message, draw in this area. You've got messages for, okay, they resized, which, will be a resize, and there'll be a paint message typically. You have what they call a non-client area paint, which is, paint the title bar. You've got all these different things that are happening in Windows. If you do a click, all those things go through, right? In Windows, in some of the installers, I can't remember who did this. It was one of the old school, like pre-MSI installers. Like it's a while back. The code for the progress bar constantly repainted it. It would keep sending paint messages, and the CPU would spend more time redrawing that progress bar than it actually did copying files. Now, here's the trick. The paint message was not getting fired while the left mouse button was depressed, because it thought, hey, if you depressed it on the non-client area, the title bar, click it and you hold it, it thinks, oh, the window's moving. I don't want to redraw the contents while it's moving, because at that point, graphics processors weren't that good. So it's like, hey, let's not beat it up until it's done moving and then we'll redraw. So you could hold down the left mouse button on the title bar and speed up your installs.
This is exactly something it's funny because I was telling my uncle, my parents had an issue with one of their cars this past weekend. It wouldn't start. My uncle came down and he took a look at it, and he told my dad, and he said, all right, well, take the shifter, pull it down, and then push it all the way back up really hard. The button at the top where you hit park, sometimes it doesn't catch, and so the machine thought it was not in park, so it would not start. Yeah,
and there's always random weird junk like that, and somebody knew at some point, and if they've been gone long enough, nobody knows, and nobody even knows that it was something to know.
Yeah. Well, it just reminded me of that, because when he and I were talking about it, I said that's so funny because computers are like that too, because you'll have these stupid little things that if you're not an expert in the field or not familiar with it, you won't know.
Yeah, and so that's one of the things that really messes up being able to refactor code, is because a lot of people know that stuff is out there, but they don't know what it is. Mm-hmm. And they, frankly, a lot of folks really just want to get by until they're not there, rather than deal with it. And I don't blame them, because it's risky to the job too.
Yeah, if you refactor and mess up, that...
Yeah, which brings us to the next point, is a lot of times you can't test for regressions. So like you make a change, it's like, okay, well, for instance, how does my app connect to a bank to make a payment? Okay, well, it connects fine to their test system, but does that work in production? Am I going to roll this thing out and, oh yeah, it can connect on, 4 out of my 5 clients' systems, but this other one has got an API key that's older, and the bank's internal system is treating it differently, even though it looks the same on the surface to me, and now it doesn't work. Guess who gets blamed for that? And so people are scared of that, because it's not even just the stuff you don't know in your code. Stuff can bite you in random places, and you had nothing to do with it.
So I guess kind of finally, my last question for you on this, what are some kind of strategies that other junior developers or even other senior developers can use when going into a refactoring?
Well, the first thing is a small locus of control. And so the idea here is start refactoring with something small. Don't do refactorings that take days, because you'll miss things. You'll have something come up. You just run into problems. Like you've got to. It's sort of like cleaning a house, right? If you go, okay, I'm going to take this small stack of papers and I'm going to organize it and file it, that's doable. If you say, I'm going to clean this entire house top to bottom, I'm going to reorganize all the closets, I'm going to, reorganize the kitchen, I'm going to do this, I'm going to do that, I'm going to build bookshelves, I'm going to do 500 things, what happens?
You end up sitting down and playing Minecraft for 4 hours.
Yeah, after you've halfway done one or two things. You got to bear in mind that these processes take place while you're still trying to deliver a product or still trying to provide a service or whatever. So you can't do it all at once most of the time. Like you've got to do a piece and then move on to what you were doing before, the profit generating activity or the activity that you're getting paid for. And then you come back and you do another little slice. Like it's a continual process if it's successful. Now, sometimes you have to do a massive refactoring or almost a rewrite, but that's not something that you typically encounter.
I just wrote the blog post for our 9 beliefs. Remember that episode? And in that, one of them was about complete rewrites. You even stated there that sometimes it does happen, but it is very rare.
Yeah, and it's rare because it's dangerous, and because while you're doing that, your competition's moving on, and so it's very risky from a business sense. Another thing to bear in mind is testability of changes. If you're picking a small area to fix, try to write things so that piece is at least testable, where you can go in there and when somebody comes to you and says, oh, your change broke X, you can say, okay, here's the inputs, here's the outputs, here's the test cases I have. What's your thing doing that's causing it to break? Because then you can write a test, get a failing test, and and keep that kind of contained. Now, granted, I don't frequently write unit tests, because most places around here of the sort that I work with are a little bit more loose on things. Like they have bigger issues. They're not the point of automated testing. But even being able to go in there and say, I'm fixing this one thing and I know I fixed it. And, being able to prove that, yes, this works. This piece I just changed works. Right with that in mind. And then you can go on. Because otherwise, if you can't, like if you're writing another piece that's like wedged up in there, it's not going to help. The next thing I would add is build a reference architecture. And what I mean by that is you want a piece of code that's complete, like a unit of code that's complete end to end. For example, at work, I am rebuilding a website. What I'm doing is I'm building a single web page that has all the pieces. It's got the master page. It's got the breadcrumbs. It's got, it's got the base page. It's got database transactions. It's got JavaScript. It's got Ajax callbacks. Building end to end all those little pieces so that I have, okay, this is the design now. This is what it looks like cleaned up. So that the next person that comes in there, if another developer comes in there, they can go, okay, this is how we do it. And that helps you too to make sure that there's not major holes, because what you don't want to do is do a cross-cutting thing and go, okay, I'm going to fix the way this thing interacts with the base page across the entire application. Well, you didn't fix the master page. And in this one little spot, once you change 2 or 3 other things over here, it blows up somewhere else. Like you don't want that. You want to get end to end. And then gradually, push out the use cases versus the other way.
Yeah, I can see that. And this kind of is building up to basically you want to make small changes at a time. And something we've talked about, you make small changes and get small wins. Not only does that help psychologically, but that can also show higher ups that may have not wanted to do the refactoring because it works. It shows them, hey, here's how it can work better. Yeah. Here's how we can move into the mobile marketplace.
Well, and it also gets rid of their fear of risk, which is a huge thing. Because, like if you do a major refactoring, okay, by the time they know you're done, it's been 2 or 3 weeks. There's been nothing produced of business value. They don't understand what you've done. Whereas if you're like, okay, yeah, I cleaned this up a little bit as it was going, they may not even notice. It's one of those things of kind of trying to try not to step on toes, trying to put yourself in a position where people feel like they can give you the benefit of the doubt.
Well, that's like, I think I mentioned this a couple of weeks ago. One of our friends who is learning JavaScript programming, had sent me some stuff that he was working on, and I saw it, and I saw some ways that it could be optimized, and so I made changes to the code and sent it back to him, and didn't hear from him for like 2 or 3 hours. And I was thinking, oh my goodness, I have made him upset. I wasn't trying to be rude. I just saw some stuff that I thought, hey, this might help him out. Then 2 or 3 hours later, he comes back and he's like completely rewritten the stuff I did.
Yeah.
I was afraid that I had stepped on his toes, and no, it just gave him so many more ideas that he just jumped right in, and that led to a lot of fun back and forth on that. So
Right, but if you're in an organization and somebody's attached to it and all that, it can really cause problems. So you want to do small wins where they go, hey, that's a reasonably good idea. I like how you're not ripping the tree out by the roots. You're just pruning it. Because then it's like, okay, this person's taking ownership of the system and improving it versus going, oh, this is junk, I'm going to burn it all down. It kills the defensive response. Think of yourself as a pathogen. You don't want an immune response. Now does this inform your decisions? To put it into a biological context?
For me, that works really well, but...
Right.
Yeah.
And you also don't want to kill the host.
Yeah.
So it is kind of pathogenic, I guess, if you think about it like that. I'm so sorry for making that particular metaphor, because I'm sure that will be misused by somebody terribly soon.
Probably someone we know.
Yeah. And so the last thing I would add is do short iterations and then integrate. If you're familiar with how version control software works, you make a branch, you do your stuff, you pull down, whatever's in the main branch, and make sure it integrates, and you push back up. Do not let a branch go off by itself. Like, don't start a refactoring branch. You go, okay, I'm going to fix this, and then I'm going to fix this, and I'm going to fix this, and then let it go like 6 months, and then try to push it back or try to pull down, because you're going to have problems. It's going to hurt. Like, you want to do the quick improvements, and then you want to get them in there. Yeah,
because the next iteration of improvements you do, you want the ones that you've already done to be in the master already.
Yeah.
You pull the branch.
Right. And the other thing is, okay, there's the cost of merging. There's also the fact that other developers, if they're working with parts of the system that you're touching, they're continuing to write code that is now incompatible.
Oh, I hadn't thought about it that way, but yeah, that makes sense.
Yeah, so you want to do, that's one of the reasons you want to do a quick win and get it in there. You shouldn't have long running branches, but especially on this, because you break all kinds of things. It's just
so in review. We started off talking about what refactoring is, just to begin with, and we kind of adjusted the definition as we got along because... Well,
it's a junk definition, like most. Definitions describe things, they aren't things. It's like numbers. They're symbols of a thing, they're not a thing. If you ever have to deal with floating point problems, you'll understand deeply and painfully.
Yeah. So we started off with that. Basically, what refactoring means is making changes that to the internal code that will make the application less painful to work with. Next, we talked about why you would want to refactor code, and to start off with, like I just said, to make it less painful and improve the ability of developers to troubleshoot problems. Also increase the speed that you can surface new functionality, improve the testability of existing code, decouple internal components, keep dependency changes from causing major rework, organize code in preparation for future operations, breaking apart components so they can be iterated on separately. If you have one app that does everything, refactoring and break that down so that you can adjust one part of that. Then next, we talked about the opposite, why you wouldn't want to refactor or what can hinder you from refactoring. That includes organizational inertia, higher-ups saying, hey, it works now, why do we need to change anything? Interpersonal disagreements about how to proceed. And Will kind of went into detail on this about people who wrote the code 5-10 years ago feel attached to it. Then you have tool chain volatility, the inability to comprehend the existing system, and the inability to test for regressions. And we just closed out with basically some general bits of strategy for refactoring.
And we're going to get into more of those in later episodes too.
Actually, our next episode, kind of a preview, we're going to be talking about technical debt, and we're going to go into a lot more detail on recognizing it and how to deal with it, and some of that does involve refactoring. That pretty much wraps us up. Before we close out, Will, what do you have for us this week for Tricks of the Trade?
I want to talk a little bit about solving the right problem. As software developers, we tend to look at stuff and go, okay, how can I technically solve this? Sometimes that's not really the right solution. I'll give you an example. Right now, as we're recording in my basement. It's a nice basement, but it's still a basement. You're under another floor. Upstairs, my daughter is running like she does all the time.
Which is odd because she's usually pretty good on Monday nights when we record.
Yeah, we changed locations too, so we're actually closer and under it. There go the booms right now. I'm not sure if she's bowling or if she's, just jumping up in the air and letting herself fall. It's pretty loud. If there was multiple of her, it would sound like a Civil War battle going on. It sounds like cannon shots. Well, how do you solve that technically? Well, you could go in here and you could say, okay, well, in Audacity, I know that the booms are this, this decibel rating and this, it's between this and this, and I could cut this out and I could fiddle with it. But what's the real solution here? It isn't tech. It's to tell the kid to quit jumping up and down right overhead.
To be honest, I'm surprised that we haven't paused the recording for you to go do that.
Yeah, well, we're just trying to get it done. And now that's very easy. This is a really stupid sample, right? But it's very poignant because it's very close. But a lot of times we kind of solve the wrong problem. And you'll see the same thing. I actually wrote a blog post a while back, I think it was last year, about hate speech on forums. How you actually solve it. It's like, well, how do you solve it? Well, you could have this heuristic that looks for these words and looks for this tone, and you could, maybe write some AI and, get a Google team involved and spend $1 billion. Or you could act as a moderator on your own forum. One of those is a technical solution. The other one is actually deal with a problem solution. But it's very easy for us as technical people to immediately jump to the technical solution when sometimes that's really not what you need to solve.
In medicine, they have a joke. A surgeon sees a patient, wants to cut on him. Internal medicine, doctor sees a patient, wants to give him medication.
And a security guard sees a patient and just wants to beat the crap out of him. I'm not sure who's solving the right problem here, but I completely ruined that metaphor.
Yeah,
I'm sorry.
well, that's all right.
But yeah, that's something to bear in mind, is that it's very easy to decide to solve a problem and to view the problem as being a technical problem when it's actually not. It's a social problem. If you have a question or comment for us, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed under Creative Commons. The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up to our email list, be sure and check out the website at www.completedeveloperpodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Thanks for listening. See you next time.